Hello Pathway students. This is a PowerPoint presentation that I put together that gives an explanation of what algebra is. I often give this explanation to my students because I feel that a lot of times we hear the word algebra but we don't necessarily understand what it means, and so I kind of wanted to break it down and hopefully give you a broader picture of what happens in algebra. So what's interesting about the word algebra is that it was actually a mistranslation, but it was intended to mean the reunion of broken parts. And I share that only because I feel that it helps us conceptually understand what we're trying to accomplish in algebra. Ultimately, we're trying to organize like terms, reunite those common values, combine them, and then identify the unknown values. So we are trying to, you see that in the subheading there, restore that which is missing. So in order to give you a clearer picture of what algebra is, I want to go back to when everyone understood math. Let's go back to what it looked like in the beginning. Alright, so this is a pretty basic problem, and we can all solve this, but in order for us to transition to algebra, we need to reorient this problem. So this right here, this is an example of the same problem. Obviously, it's just been rewritten horizontally, and the primary reason we do that is it helps us as we go further into algebra. But we can solve this just like the last one. We combine the like terms and ultimately we get that our missing value, which we are now going to represent as a symbol of x, that it's going to be a value of 10. The problems that algebra are designed to solve are not these kinds of problems, but these kinds of problems, where ultimately, so you see the problems, the difference here is the problems on the top, we can see that we have both of the values, both of the known values on one side of the equal sign, and the missing value is on the other side of the equation. So, but on these two bottom sides, we can see that we have a known value with a variable, and that they're both set equal to a known value. And so fundamentally, this is the kind of problem that algebra is trying to solve. So these are the concepts, these are the four fundamental concepts of algebra that I'm going to go over right now. And when you have a better idea of what these are, it gives you a clearer picture of what algebra is as a concept. So these are what algebra is. All right, so we're going to go through them one at a time. So the first one is expressions. First, I'm going to give you some examples, and then we're going to talk about what algebraic expressions are. So here's an expression. Here's another expression, there's an expression, and another expression. So ultimately all these are expressions, and what's important about expressions is that you can't solve them. All you can do is rewrite them, combine them, simplify them is often the word that's going to be used to describe what we're going to do with these expressions. These, and this is the best this is the best definition that I have for an expression, is that they're not equations. Okay, so an expression is numbers and letters written together in some form, but ultimately they are not in an equation. So what's an equation? Well, here's some example of some equations. This is a screenshot that I took of the last assignment that we had given. I wasn't able to type these, and so this is the, the best that I had. So ultimately the best explanation for an equation is that it is an expression set equal to another expression. That's fundamentally what we're talking about. It is the equal sign that makes it an equation. And I realize that maybe this is something that you all understood, but it was significant to me because once I identified the difference, it became much easier for me to figure out what I was supposed to do. As you go through your assignments, take a look at the directions because the directions will tell you, am I solving the equation or am I simplifying the expression? There are different processes in each case, and it's important to differentiate between which one you're working with, an equation or an expression, because different rules apply to each. Ida earlier on March 1st had shared within the group an algebra cheat sheet, and if you didn't get a chance to look at that, I would encourage you to do so. It does a good job kind of talking about what rules to use and when. Alright, so with equations, typically we're trying to solve the equation. Sometimes there's not a solution, sometimes the solution will be undefined, or there can be potentially infinitely many solutions. And these are kind of complicated, and we'll get to these at another point. But just be aware that that's what is potentially going to happen. All right, so then the third concept of algebra that we're going to go over are variables. And so most of you are very aware of the most common variables are typical x or our y. Some other examples are going to be pi. Pi can be represented as a variable, or the square root of 2. Both of these are irrational values. And that's not to say that they are variables, but they're irrational. And when I say irrational, that means that they go on forever and they don't repeat. And so oftentimes the same rules that apply to to irrational values can be applied to variables, and so it's kind of a good idea to think about irrational values as variables because that'll help you with the rules for them. And then finally, potentially, we could have an equation that's nothing but variables. So I want to talk about, there's two definitions for variables, and hopefully it helps you identify kind of the first steps of algebra and then the transition to where algebra fundamentally will be going. So the first definition is the one that you're probably most familiar with, and that is that it's an unknown constant or an unknown value. And the reason why I use the word constant is because it helps think about it in relation to the next definition, which is that a potential variable is a changing value. And oftentimes the way that we express this is that we have x, which is commonly our input, or y, which is commonly our output. And so as x changes, as our input changes, so will our output change. Hence, we have an input and an output, and this relationship will happen whenever we have an equation that has more than one variable in it. And x and y are the typical changing values that we're going to talk about. And so we're going to be transitioning from just equations to functions, and it's going to get a little bit complicated, but with that idea of variables and the two different definitions of variables, hopefully it helps you make that transition. All right, then the next one is inverse functions, and ultimately what algebra is going to be doing is helping us solve for missing variables by using inverse functions. So this is how it's going to work. An inverse function is the function that will reverse the current operation influencing the variable we are trying to solve for. Wow, that was a mouthful. What did I just say? Well, here's an example. So let's say I have this equation. 4x minus 5 equals 2x plus 1. So ultimately what we're trying to do is we're trying to get all of our x's together on one side of the equation and all of our numbers on the other side of the equation. So there's a lot of different things that I can do here, but let's start with the constants, the 5 and the 1. So from the outset, I want to solve for the x on the left side. So I'm going to try to move the 5 to the other side of the equation. And what I say right here is that the inverse function is the function that will reverse the current operation. So what I want to identify first is what is the relationship between the variable I'm trying to solve for and the number I'm trying to get rid of. And so the relationship in this case is subtraction, and the inverse of subtraction is addition. So I'm going to add 5 to both sides, and that's ultimately what's going to get rid of my 5, because a negative 5 plus 5 is 0. And so if I add 5 to the left side, I have to add it to the right side as well. And by doing so, my 5 is gone, and now I have then 4x equals 2x plus 6. So now I want to get my 2x to the other side of the equation, and so I ask myself, what's the relationship between the 2x and the 6? And the relationship in this case is addition, and the inverse of addition is subtraction. So I need to subtract the 2x to get rid of it on the right side. But if I subtract it on the right side, I have to subtract it on the left side. And now 4x minus 2x is 2x, and now 2x equals that 6 that was there earlier. So now the relationship is between the 2 and the x is multiplication, and the inverse of multiplication is division. And so I divide both sides by 2. And by dividing by 2, by dividing the left side by 2, I also have to divide the right side by 2. And 6 divided by 2 is 3. And so fundamentally, that's what the inverse function is doing, is it is undoing whatever the relationship is currently with the number and the variable you're trying to solve for. So the six most common inverse functions that we will use in algebra are addition and subtraction, multiplication and division, and squares and square roots. Now there are more inverse functions, and we will get to those, but these are the most common ones, and I'm anticipating that these are the ones that we will be using strictly for this course. So just as an example, I wanted to show you this. This is the quadratic formula, and this is a great example of how all 6 inverse functions are being used together. So you see the negative in front of the b, so that's subtraction. You see both an addition and a subtraction at the same time, and a square root sign, and a value squared, and you're subtracting, and then you have 4 times a times c, and then a big divide sign, and then a 2 times a. So all of our inverse functions are being represented in one equation, and that's probably one of the reasons why we use the quadratic formula, because it gives us an opportunity to work with all of the values at once. Hopefully this didn't confuse anyone, and hopefully it helped you kind of see the big picture and maybe identify some of the vocabulary words that we've potentially been hearing but maybe haven't put it all together. So in closing, I just wanted to remind you that ultimately algebra was trying to restore that which was missing, and ultimately we're going to do that through these 4 principles, through expressions, equations, variables, and inverse functions.